Hi, I'm Neil, and I'm a co-founder of Bombfall. Now, if we're an attacker, our goal is never just to attack a BPF map. Our goal, fundamentally, is to attack a BPF program and somehow neutralize it, because whatever security BPF program is in place, it's blocking us, the attacker, from accessing some sort of protected resource. Now, we're attacking BPF maps because directly attacking a BPF program is quite hard. Now, attacking a BPF map makes it a whole lot easier to control this BPF program because most BPF security programs read their security policies from a BPF map. If we control a BPF map, we control the BPF security policy. Well, now we want to attack BPF maps, but how do we do it? Well, BPF maps are shared objects, so suddenly it becomes a lot easier to get access to these objects as a malicious actor because they're fundamentally made to be accessed by multiple processes. So, if we can get access to this object, which is not too hard in the grand scheme of things, then we can manipulate this BPF map that we have access to, thereby shutting off a security policy, which allows us to do bad things on the system. So, today we're going to be going over two exploits. One that involves the BPF syscalls, and one that utilizes ptrace to steal the map from an authorized process. So, the first attack is quite simple. We're just hitting a BPF syscall, directly asking for the map, getting it, and mutating that map. This is possible because BPF doesn't really have any policy control around who can access a BPF map. If you have elevated privileges, BPF gives up the map. So, I'm just going to run my Bombfather agent. You can run any BPF program you want. I'm just using Bombfather for this demo. And I'm running it with no security policy. We just want to really attack the Bombfather agent itself. And I'm not running any map security, nor am I blocking ptrace. So let's run sudo/attacker agent with my config. So my Bombfather agent is running, and now I just need to run sudo bpf tool map list. And essentially, I'm just hitting a BPF syscall with BPF tool, and I was able to get all Bombfather maps. Now, what this means is that I'm able to access these maps, which means that the whole Bombfather agent is now compromised. So, what do we do about this? Well, this attack purely comes from the fact that the attacker is using a BPF syscall, right? They're accessing the map using the BPF syscalls. So if we, as a BPF agent, somehow secure the BPF syscalls and we add a policy to that so that no one can really access them if they're not authorized. If that BPF syscall is for accessing one of our BPF maps, then we ideally should be secure. And that's actually what Bombfather does. So if I just turn off map security, and again, you can do this with any BPF agent, you can just write an LSM hook in your BPF code, which restricts access to BPF maps if that map is one of your eBPF maps. So if I run my agent, the agent is running, and now we want to run sudo bpf tool map list, right? We're hitting the BPF syscall again. And now we get two maps, right? These are non-Bombfather maps, so we're not really restricting them. And then it gets an operation not permitted because it was a Bombfather map. We can see it was trying to access the Bombfather execv map. So that was pretty simple. And it's not really too hard to block these attacks. And if someone is really trying to access one of your eBPF maps, they're most likely going to access it through a BPF syscall. Now, there is an edge case that allows attackers to still attack BPF maps. And it only works on a single type of, group of BPF maps, called BPF mmapable BPF maps. Essentially, to understand why we'd even use these maps, I'm just going to use this notepad. So, we have these normal BPF maps, right? They're relatively slow, and we have our user space program, our eBPF program, and our eBPF map, a normal eBPF map. Now, if we're reading a lot of data from our user space program from this eBPF map, let's say we're logging something from the kernel space, I don't know. But every single time we need to access that data, we're copying that data because it's kernel memory. We can't just directly access that memory. So that's really expensive, and we keep on doing this, then suddenly these costs start to add up. So what we can do is use a BPF mmapable map, which is relatively fast. Essentially, we turn that BPF map into a shared VMA back page, and that memory region suddenly becomes accessible by anyone with a file descriptor to that map. And then we can just memmap over that file descriptor, and suddenly we can directly access that memory. What this does do, though, is expose a security problem. You see, we currently are gating off the BPF syscall. So if you are a good process, that means we allow you through, or else we don't allow you through, right? Well, with memmap, suddenly you're never going through the BPF syscall. So essentially, now if this attacker can get a file descriptor by some way or form, they can access our map and we can't really stop them. Now, the attacker needs a file descriptor. So what they can do is ptrace our user space program, which was allowed to get that file descriptor. Remember, we have to allow our own user space program to get a file descriptor to a map, or else we can never write a security policy to it. So it can ptrace our user space program, steal the file descriptor from it, and then use it by itself to memmap it. And that's actually what we're going to do for our next exploit. We're going to ptrace a user space agent, we're going to memmap over it, and we're going to zero out some maps. So we actually put this all into an attacker code base. It's in the bombfather tools repo. Essentially, it's a single Go file that just calls ptrace. Then we get the file descriptors, it calls memmap, and it puts in one easy-to-use package so that everyone can play around with it. And we have a lot of comments on the code, so if you really want to understand this problem better, I think you guys should check it out. And there should be a link in the description below to this. Now, let's actually run this. I'm going to turn off map security so that we can make this demo a little easier to run. Essentially, what we're doing here is we're just not using a BPF syscall, but if we do use a BPF syscall, we can actually see what maps we're attacking. So I run sudo agent, right? Running the agent, no security is on, and I'm going to run my attacker code. To do that, I first need the PID of my agent so that I know what to ptrace. So I have my agent here. Let me run sudo/attacker with that PID. Right? And now it spits out 4 maps that we can attack. There are only 4 maps they can attack because the other maps are non-memmapable maps, so we cannot just memmap over them, which means we can't attack them. Now, 3 of these are dynamically generated. We only care about this bombfather test map. It's a test map because we at bombfather don't actually currently use BPF memmapable maps. We will in the future since they're really highly performant, but currently we don't. So we're going to click enter, and we can see the 3 keys, all with the value of 1. And our goal right now is just to turn these values to 0, right? So again, I'm going to click enter, and we get the file descriptor by ptracing over it. We copy it to our own local file descriptor so we can play around with it. We find out where the values are, and we essentially zero them out, and we can see all the values are zeroed out. So this is not good at all. Essentially, we were able to attack our bombfather agent without a BPF syscall. But this whole attack roots off of the fact that we were able to get this file descriptor. So if we can't get this file descriptor, we can't memmap over that map, we can't zero it out, we can't even see it. Now, there are only 2 ways an attacker could get this file descriptor. They could get it from our user space program, or they could get it using a BPF syscall. And no one else except our user space program can use the BPF syscall to access the map. So it can only get that file descriptor from our user space program. So if we block ptracing on our on our user space program, then suddenly it becomes impossible essentially to get that file descriptor. And that's exactly what we can do. So if I turn on ptrace security and I rerun our agent, now if I say I get the PID of my agent, and we run sudo attacker with this new PID, we see there are no mmapable BPF maps. That's because it can't even p-trace the process. If it can't p-trace it, it can't even see what maps are there, let alone attack them. So this is, and also we can see we blocked all these p-trace attempts on our process. So if we as a good BPF program really want to have a secure BPF security program, we ideally should be blocking these two attack vectors, which isn't really too hard. And once we understand that if we block the BPF syscall and if we block p-tracing on our user space agent, essentially no one can access our maps, because fundamentally you either need a file descriptor or you need the BPF syscalls to do anything with these BPF maps. Thank you for watching.